Hi, Matt Allington here, and today I'm going to do another one of these projects where I'm actually going to build a report in real time. But what I'm going to do is I'm going to solve a particular problem that I've got, and then I'm going to do it in real time using Power BI to demonstrate the process that I go through to solve problems. Now, if you want to be good at Power BI, you need to get practice. So if you're going to build data models and build reports, you must get practice. And one of the best ways to get some practice is to find something meaningful that you can work on. It can be something in your personal life, something in your work life. It could be some voluntary work that you do. So find something meaningful that you can work on that will help you become better with Power BI. So let me share with you the problem that I'm going to try and solve today. So the problem I'm going to work on today is I want to determine how large should my rainwater tank be. So we're going to do a bit of a residential build. We're going to build a new residential property, and the council is telling me that I need a 50,000 litre water tank. So for those in the US, I think it's like 3.8 litres per gallon or something like that. So divide that by 4. So let's call it 12,000 gallons, close enough, water tank. Now that seems like a lot to me, and I want to go back and have a discussion with the council because I don't want to put in a 50,000 litre tank. I'd rather put something smaller, maybe 20,000. But if I'm going to have that conversation, I need to have some meaningful data to be able to talk to them about. So I'm going to work out, is 50,000 litres too big, too small, or what? And so in order to do that, the approach I'm going to take is this. So I've got my house, and my house has an area of the roof. Now look, there's a pitch on the roof, and rain coming in from an angle might change the area. But for the sake of the exercise, I'm just going to take the size of the floor plan of the house, which in my case is 167 square meters. So, geez, I used to be able to do this. I want to say it's like 10 times or 9 times in square feet. So let's say 1,500 square feet. Something like that. So 167 square meters is the floor plan. So I'm going to say that's my roof site. It's going to rain. So I want to work out how much rain do I collect on my roof, which will obviously go into the tank. And then I need to work out how much water am I going to draw out of the tank if it was fully plumbed for water tank usage. And therefore, on any given day, what would the level of the tank be? And is it reasonable to expect a 50,000 litre tank? So that's the problem I'm going to try and solve, and I'm going to do it one step at a time and show you how I go about it. Alright, so I'm going to do this in Power BI Desktop. I could equally do it in Power Pivot for Excel. Frankly, I just prefer the user interface for Power BI Desktop. Power Pivot for Excel doesn't get a lot of love anymore, and I just prefer to do it in here. Okay, so the two bits of information I'm going to need. I need to know how much water is coming in to my tank and how much water is going out to my tank. So I need to get information to solve both of those things, and then I feel I can work out what the level will be on any given day. Okay, now to solve this problem, I'm going to go over and find a rainfall website. And so that's what I've done here. This is the Australian Bureau of Meteorology, and the location, so this is a family property which is going to be redeveloped, which is close to Swan Reach in South Australia. You can Google it. It's basically out in the middle of nowhere on the River Murray. And this website seems to give me rainfall data, and you can see already this is millimeters, right? So on the 24th of January there was 6.6 millimeters. It's nothing. 25 millimeters is an inch. So this is a very small amount of rain. So we've had a quarter of an inch for the month of January, so not a lot of rainfall. But I'm definitely going to need this, and I've been able to come here and download a CSV file that contains literally the daily rainfall that's relevant to the property that we're looking at developing. And so if I show you that data now, I'll just jump over to Excel. Okay, so here's the CSV file that I've downloaded. So this looks like maybe it's the station code. I don't really need to worry about these two things too much, but basically what's important is the date and then also the amount of rain. So this goes back to 2006, which is really good. When I talk to the council, I can say, well, here's the data for the last 15 years. I can demonstrate, well, I hope to be able to demonstrate that there is no way I could fill my tank in 15 years, and therefore I don't think I need that size tank. So I need this data, and so I'll go ahead and load that now. Okay, so I'm back in Power BI Desktop, so I'm going to get data It's from a CSV file. This data is not going to change. So I'll just come in here and bring in that data. I need to do a bit of manipulation. I'm going to need to do some time intelligence calculations. So I will create a calendar table as well. So here's my rain data. I don't think I need these two columns, so I'll just multi-select, right-click, remove columns, and I want to turn this into a date. So I think the easiest way would be just to multi-select, transform, merge the columns. I'll put a separator. In Australia we tend to use a dash for a date. I'll call it date. It's technically not a date yet, but I'll go date, and then this is still a text column, but now that I've got it merged, I can come up and change it to a date and it should correctly pass into the date. Of course, this is international date format. All right, so here's the rain over which was measured. I'm not sure. This is basically a day level, so I don't need that either. I don't know what this quality is. Maybe I'm not going to worry about that either. So I'm just going to keep these two columns, remove other columns, and because I don't need these rain days if there's no rain, I'm just going to come in here and filter out the nulls. And in fact, I'll filter out the zeros as well, because it's obviously such a small amount of rain that it's not really measurable. So there I have it. I've got my rain data in millimeters. Okay, so let me just go ahead and we'll close and apply that, and let's go and have a quick inspection of that data. Okay, so here's the data loaded. If I come in here, you can see down here 1495. So this is from mid 2006. So what is that? 16 years or 15 years, orders of magnitude. There's only been 1,500 rain days in 15 years, 100 days a year. And okay, so now I need a calendar table. So the way I like to do my calendar table is I keep a copy of my calendar table in OneNote. And so here I am in OneNote, and here is my calendar table. So I just copy this code, Control C, and I need to go back in and get into Power Query. I'm going to create a new source blank query. This is going to be called calendar. And once in here, I'll switch to advanced editor and just replace everything with that code that I cut and paste from OneNote. And I believe this is a calendar year. So yes, this one does calendar year. And the way I've set up this calendar table is I have a start date and an end date, which I can hard code. So my start date, it needs to start in 2006. And the end date basically takes the current year, and so I'm currently in 2022, takes me through to the end of that year. So this is a good practice for a calendar table. If you want to learn how to build this calendar table, I do have a separate blog and you can refer to that. I'll put the link in the blog article and also in the video. All right, so let's go close and apply. I'll go ahead and join the tables. I'll join the date up to the calendar table. Now notice this is one-to-one because, and in this case, obviously my rain data, I've got data just for single rain day, so it is going to be one-to-one, but this is not the best way to structure a relationship. So this is where you have to build some experience. So the better way to set up your relationships is one-to-many. So sometimes these automated processes are not really your friend. So I want the rain data to be a many-to-one relationship to the calendar table, and I want single cross-filter direction. So that's the correct way to model this data. All right, it's also good practice to come in here and hide the column on the many side of the join. So I've done that. And when I do that, I can come over here. And so now I can pick on any given year. So I'll just bring the year in and I can just do an implicit measure and I'll turn that into a matrix. The year comes up here. And so now you can see the total amount of rainfall per year. I need to do a couple of things to tidy up. So my year column, in fact, all of these columns really should be non-additive. I don't want to add up the years. I don't want to treat them as numbers, even though they are numbers. The easiest way to fix this is to jump over here, come to the calendar table, select all the columns. Once you have them all selected, come down to advanced, summarize by none. That will change all of those columns. Even though they're numeric, when I add them to a visual, they won't be treated as numeric columns. Now I also need, in this case, to change the data format to be a whole number, for the year, and that's basically solved that. All right, so you can see here now, it's also useful just to visualize this. This is useful to visualize your data over time. So I can see that, you know, the peak year for rain was 2011. I had 436 millimeters. Of course, the question is, how much rain would I gather from my roof if I had 436 millimeters of rain? So let me set out about writing a measure to work out how much rain. So I think I will just come and write an explicit measure for rainfall. I always prefer to have explicit measures. So rainfall is simply the sum of the rainfall in millimeters. It's probably good practice to put millimeters here so that I'm clear what the units are. And I probably will keep, say, 1 decimal place. I'll add thousand separators, particularly for the total. And there we have my rainfall in millimeters. I thought I'd change that to 1, but let's go back and change that to 1 decimal place. All right, so there's the rainfall. Now I need to convert this into water gathered, and this is going to be based on my roof area. Now, rather than hard code my roof area, I think I'm going to create a variable. So here, if I multiplied these millimeters by the area of my roof, I should be able to work out cubic meters of rain that's been gathered. So I'm going to create a measure, and I'll call this measure my roof area. And I'm going to hard code the number 167. So this is the roof area in meters squared, and it's 167 meters. So this would be the equivalent of putting like an exchange rate in a cell in Excel and then referring to that cell. It just means that if you want to use that inside another formula, you can refer to the formula, and then you've got one location to go and make that change. So it occurs, I mean, if I bring that in there now, you'll see that I get the 167 all the way down. So if I multiply the meters squared, the area, by the rainfall, I'm basically turning this into cubic meters, or water capture. Now this is in cubic meters at the moment, but it's just the roof area. This is a bug in IntelliSense. It should not put the table in front. It's the roof area multiplied by the rainfall. Once again, it shouldn't put the table name in front. And so this is now in cubic meters. Of course, if you did this in Excel, you would know how to do it. I'm showing you how to do it here. So this is cubic meters, and this is the benefit of the metric system. If I want to convert cubic meters to liters, I just have to divide that by 1,000, because there's 1,000 liters in a cubic meter. And so this is now water captured in liters. Okay, now something's wrong, because I definitely had more than 46 liters in a year. So let me just take this off for a second. Delete this one. So intuitively, this seems more correct. So something's wrong. So the roof area is in meters. In fact, the rainfall needs to be in meters as well. So this is rainfall in millimeters. So if I wanted to get cubic meters, I'd have to multiply the roof area, 167, by 0.276 meters. So I've actually already got the divided by 1,000 catered for, because the millimeters is not in meters, it's actually in millimeters. Okay, so this is correct then. So 46,000 liters in 2007. So that's how much been collected. Now, of course, if I didn't use any rain and I had an unlimited size tank, I could work out what's the long-term total amount of rain that's been captured. So to do that, I'm going to use a time intelligence function, and I call this lifetime to date. So I'm going to create a new measure, and this is lifetime water capture. And so this is going to be time intelligence. And so I need to use a calculate function because I'm going to manipulate filtering behavior. And what I need to do is I need to keep everything up until the last date with the filter applied. So when I have year 2007, the last date that is in this filter is 31st of December 2007. So what I need to have here is I need to know all of the rain from 2006 up until the 31st of December 2007. So let me just do this just for explanatory purposes. So I'll create a variable, and I'll call this the last date in filter, and the formula will just be max of the calendar date. And then I'll return last date in the filter. So if I put this is a work in progress measure, you can see that this is correctly telling me that if I've got 2010 in my filter, the last date is 31st of December 2010. And so now I can use this inside my formula. I want to calculate the water captured in litres, and I need to filter all the calendar table. So I need to remove all the entire calendar table, and then I need to go and manually put a new filter on the calendar date is less than or equal to that last date in the filter. So 2 brackets to close that off, and let's see what that gives us. I like to put a conditional format on here because this will help me validate whether the formula is working as expected. Yes, it's working as expected. I'm starting off with 9,000 litres in the first year, or it was a part year, and then basically it increases over time forever, so lifetime to date water capture. All right, so this is the first thing I need to do. Now the next thing I need to do is to work out how much water am I going to consume on any given day. So I need to go to the internet to find an answer to that. All right, so here we are. Dr. Google tells me that we need 340 litres per person per day as the daily water consumption in Australia. Uses about 200 litres of drinking water. So to me, this number might change, and also the number of people in the household might change. So if I'm going to build an extensible tool here, what I think I'll do is I'll create a few more measures that are effectively parameters to be able to control the inputs. So the first thing I'll do is I'll go and create a new parameter. So I'll go to the modeling tab, I'll create a new parameter, and this parameter will be daily consumption. Okay, so it's be a whole number. So 0 up to 400. And let's increment by 10 litres. And the default will be that number that I had before, which is 340. And I'll add a slicer to the page. And so what happens when you create a parameter like this is that a new table gets generated under the hood. So I've got this new table. I call this a disconnected table. And this table contains all the values from 0 to 400. And there is a slicer. So what this slicer does is, I'll just change, I don't like this type of slicer. It allows me to put a filter on that table. Now when I put a filter on that table, in this case 100, there's also a measure here. And if I bring that measure onto the canvas, and I'll turn it into a card, when I select one of the values in the slicer, this measure tells me what that value is. And so therefore I can insert this measure into my calculation, which I'll do in a moment. Now the second thing I want to do is how many people are in the household. So I'll do another parameter, and I'll call this people in household. And a whole number, it's between, I might do 0 because this is a holiday house, sometimes there are no people there. And let's just do up to 6, incrementing by 1. And we'll put the default as being 2, and we'll also add a slicer. So exactly the same as before, it creates this disconnected table. I'll change the slicer to be a list. And I've got this measure. So if I put another card and I bring the measure into that card, when I select a value, it tells me how many people I've selected. All right, so the logic for water consumption then is that I need to know how many days have elapsed, multiplied by the daily consumption, multiplied by the number of people in the household. So I'm going to write a lifetime water consumption measure. So that's the next thing to do. Now this is, where do I put this? I'm going to put it in the rain data. If I'm going to do this, I'd probably rename this data. And I would probably also come in here and hide this column. And once you hide all the columns in a table, the table gets this little measure icon and it floats to the top. So this is pretty useful. All right, so I'm going to do a new measure and I'm going to call this lifetime water consumption. Really good practice to give good descriptive names to your measures so that you understand what they're doing. So the first, now I'm going to break this into pieces. So the first thing I want to do is work out how many days have elapsed. All right, so I'm going to use the same pattern as before. So I'll do a variable, last date in filter. I think this is the same as I had before, will be max of the calendar date. And then return the last date in the filter. All right, so it's good practice just to test these things before you move on. I did it a moment ago, so I expect it's going to work. So there's the last date in the filter. So now I need to work out how many days have elapsed since the beginning of time. And so I'll do another variable. This is elapsed days. And that will be equal to, and sorry, there's no equal there. And so elapsed days will be calculate. I need to count how many rows there are in the calendar table. So count rows in the calendar table, but I need to apply that same filter. I have to remove the filters from the calendar table, and then I want to put a new filter on the calendar date is less than or equal to the last date in filter. So that should work, and then return elapsed days. So let's go and have a look and make sure that that's working as expected. All right, so you can see it's growing over time, 1 year, 2 years, and so on. Now, there is a simpler way of doing this formula, actually. This is a calculate. But if you think about it, this filter function returns a filtered copy of the calendar table up until the last date. And so I could simplify this just by doing count rows of the filtered copy of the table. That would also, I don't need that. So that would also give me the same answer, perhaps a little bit simpler syntax. All right, so now I know how many days have elapsed. It's just a matter of multiplying that by the daily consumption, which is this one. IntelliSense is wrong. I shouldn't have the table name. And I also have to multiply it by the number of people, which is this one. Remove the table name. I think this is going to be fixed in March or April. I'm hoping it's going to be soon. So what does this give me? Number of daily consumption in litres multiplied by the number of people in the household multiplied by the number of elapsed days. So I might just put litres here, just so I'm clear what it is, and let's go ahead and have a look at that. I'll just tidy this up and then show you what's happening. Okay, so I've just done a little bit of tidy up. I've just rearranged the visuals on my page. So I've also renamed some of these measures. So this is the daily consumption per person. I've currently got it 170. I think we said it was more like 370, but let me take something mid-range. I'll say 250 litres per day. And I'll change the number of people in the household to 2. And with that, you can see this is the consumption that would occur with this number of people in the household consuming this amount of water. So now, of course, what I need to know is what is the level in the tank. So the next thing I need to do is basically add up all of the water that goes in and subtract all the water that comes out and see what the balance is. So I'm going to do that now. So this will be litres in tank. And so that'll be equal to the lifetime water capture, subtract the lifetime water consumption. So at this point in time, it's going to assume that I have water in the tank from day one. Of course, it could go into negative, and that's not realistic. Let's come in here, we'll do this. Whole litres, I'm sure, is going to be fine. And we'll put that in here. So now that we've got this, you can see that, well, I actually don't need these other two numbers. So for simplicity, I'm going to remove those two and just have, I don't need the water captured in litres. And in fact, what I might do to visualize this now, I'm going to turn it into maybe a line chart like this. And I don't need the rainfall. And in fact, I'm going to bring the date in onto the axis. And so here you can see that basically if I started with effectively an empty tank, I would just continually go negative. Now this is not realistic because I can't use water that I don't have. So the next thing I need to do is to make this more realistic. Now the simplest way I can think of doing this is, what if I was to assume that my tank was full on the day that I purchased it? So what I will do is I'm going to create another measure here, and this will be my tank capacity, and I'm going to set that at 50,000 litres, and of course I could set up a parameter for this as well. And so what I need to do is I need to come and change my measure. So the lifetime water capture now is going to be not only the water that has come through rain, but I'm going to add the capacity of the tank. So basically I'm assuming that the tank is full on the day that I purchase it, and of course that's not realistic, but it just helps me visualize what's going on. And now even with that change, it's always a negative, so I think to understand what's going on I need to switch this over to a date view. And so then basically this chart will show me every single day for the last 15 years and what the level of the water tank was, assuming that I started with 50,000 litres. Now this is quite a heavy calculation because I've got to do the calculation 365 times over 15 years. So probably would be good if I come in here and just put a filter. Let's just have a look at 1 year's worth of data. And so now you can see more clearly that I'm starting with 50,000 litres in January, but 2 people living in the house consuming 250 litres per day. This tank basically becomes empty on the 11th of April, something like that, 10th of April 2006. And this is taking into account the rain. Now the rainfall in this case didn't really start, I didn't start to collect rainfall until mid 2006. So what I should do then is change my calculation so that I've only got the data, say, from 2007. So I'll switch this over to 2007, and I think what I'll do is I'll go back and I will remove the data in my data table, and I'll also start my calendar date. So I'm going to go back in and I'll edit the query, and I'll start my calendar table from 2007. And I'll also make sure that I only load my rainfall data is after, so on or after 1st of January 2007. Just gives me a cleaner starting point, and it rained on the 6th of January, so I think that'll make it a little bit easier. So let's go back and have a look at what that does. So this is obviously going to update now because my calendar table starts on 2007. And so assuming that I had 50,000 litres in my tank on the 1st of January, you can see this is the level. And so by basically the zero mark here is sort of by mid-year, even with the amount of rain falling, my tank is going to be empty. All right, so this is quite a tricky little problem. What I might do is I'll switch this over to a table view. So I can work out the litres in the tank, but that's assuming that I'm always consuming the daily consumption rate, assuming that this number can go negative. But that's not the reality, because the water captured is obviously going in. I don't have a formula for the consumption going out. But in order to make this work, I really need to only subtract consumed water, which is the daily consumption for the household, if there's any water in the tank. But I can't tell if there's any water in the tank unless I pre-calculate this litres and tanks. So I think I'm going to get a circular reference. I can't work out lifetime water consumption in litres unless I know how much I draw down from the people times by the consumption. And so this becomes a circular reference. So I think I might take a slightly different approach. In fact, what I'll do is I'll just go back and I'll duplicate the page. And I'll just try and take a slightly different approach here. So with this new page, I'll have a look at my daily rainfall. So in more correctly, how much water has been captured in litres per day. And then I know my consumption, so how many days will this last? And so you can see over the last, I think it was 15 years, the maximum amount of water I captured in any one day was 5,000 litres. So another way of looking at this would be how long does that rain last? So I'll say days coverage would be a good name. So I need to divide the water captured by the consumption per day, which is the daily consumption per person multiplied by the people in the household. I've got to get rid of these tables again. So close that off. And let's have a look at how many days coverage we get. So the heaviest rain event in the last 15 years gave me 11 days coverage and would require me to have a 5,000 litre tank. If I was to move away from the date level and go up to a month level, if I assumed the best would be April 2007, during that entire month there was 11,000 litres and it would last me for 22 days. So I think that's all the information I need. I'm going to prepare this now and send it to council, and I would be making a recommendation that based on the rain history in my region and the roof area, that I don't need a tank any bigger than probably 15,000 litres. Okay, so I did a bit of work off camera to prepare what I want to send to council, and this is what I've come up with, so I want to share with you what I have. I've created a brand new report. I've used the model that I've been working on throughout this video. You can see here that this table contains the months and years, and it shows me the total monthly water capture. And so the highest monthly water capture ever was in March 2011, or when I say ever, within the last 15 years. And that would have given me 43 days coverage, which of course would mean that I could use, if it started on the 1st of March, I could use that water in March and April. But the key point being that even if it all fell on the same day, it would only be 22,000 litres. Now I have over here, this is a small multiple chart, so this is relatively new, and I've put the water captured in litres with the small multiple on years and the axis on months. So what this allows me to do is to say, well, let's pick the biggest month, and you can see it here. And in fact, cross-filtering works. So if I say pick the biggest month, March, you can see that this is cross-filtering here. And I can see that there was a very heavy rainfall in March, but nothing from then on. So even if I had 43 days coverage here, there is no way that there is going to be subsequent rain events that would allow me to consume more. I guess possibly what could happen is that there could be a rain event here. I had 11,000, and then the next month I had 30,000. So, you know, combined, that's probably going to get me to 60 days. So there's really not going to be massive incremental storage as a result of that. Of course, I can come up here and say, well, what would happen if there were 4 people in the household? Of course, the coverage is going to be a lot less, so less coverage with more people, and same if they consume more water per day.